Good morning, students. We completed lesson 4, that is the refraction of light at a curved surfaces. In that lesson, I completed the theoretical part, explanation part, and example sums are given in the textbook. 5 example sums are given. So in this video, I'll start to explain those example problems. So I'll start with the first example. So all these problems are based on the refraction of light at curved surfaces. Actually, in the refraction takes place in two surfaces. Refraction at the plane surface and the refraction at the curved surface. For based on these two surfaces, we have two different formulas. For example, refraction at the plane surface. So first I'll start with the refraction at curved surfaces. So for that we have the formula N2 by V minus N1 by U is equals to N2 minus N1 by R. Once again I am repeating. Refraction, what is refraction phenomena? Light travels from one medium to the another medium. While it is traveling from one medium to another medium, its speed changes. Based on the medium, its speed changes. Due to that, the light ray bends and travels. So the bending of the light ray is known as refraction of light. So this refraction, it takes place at plane surfaces and at the curved surfaces. So when the light refraction takes at the curved surface means we have to use this formula. We don't want the derivation of these formulas because this derivation is given in the colored pages. I said earlier in the videos. Now, this is for the curved surfaces. Now, refraction at plane surface. For this, we have another formula, that is N2 by V minus, actually for the refraction at the plane surface, this R value becomes infinity. So infinity means we will get 1 by infinity. So N2 minus N1 into this, will take it as 1 by infinity. 1 by infinity means its value becomes 0. 0 into this, totally this becomes 0. You don't want all this explanation, just you learn the formula. So for the refraction at the plane surface, we have the formula. This becomes 0. 0 means we have N2 minus N1 by U. Then if you take this one to another side, you will get N2 by V is equals to N1 by U. So based on these two formulas, we have to solve the first example. Now, I'll read the problem. A bird is flying down vertically towards the surface of water in a pond with constant speed. There is a fish inside the water. If that fish is exactly vertically below the bird, then the bird will appear to the fish to be. Here 4 options are given. So out of these 4 options, which one is correct, we have to find out. This is the problem. So once again, and for this problem, a figure is also given in the textbook. Once a bird is flying down vertically towards the surface. Here see, I don't know how to draw the bird, just simply I drew the bird shape like this. This is a bird. Okay, a bird is flying in the air. When it is flying, it is moving vertically downwards. This bird, while it is is flying vertically downwards like this, towards the surface of water in a pond. So this one, it is a pond. Okay, in this pond, above this water pond, the bird is flying vertically downwards like this. Then with a constant speed, there is a fish inside the water. So at what direction the bird is flying vertically downwards, at the same direction in the water, a fish is there. A fish is there. If that fish is exactly vertically below the bird, then the bird will appear to the fish to be. Means a bird is in the air medium, fish is in the water medium. Here two mediums are there. But for the person who is observing the bird in the same medium, there is in the same medium, actually the bird is coming this much distance only. But for the fish, because the fish is in another medium, so for the fish, where is that? The bird appear when the bird is flying vertically down towards the water. In the water, fish is there. So for the fish, the bird, how the bird appears, whether the bird is coming farther away than its actual distance, closer than its actual distance, moving faster than its actual speed, moving slower than its actual speed. Means for the fish, the bird is coming. Means for the fish, the bird appears when the bird is coming or the flying farther from the actual distance or closer. That is one option. Next, the speed. Next, moving faster or moving slower. Why? Because the bird is in one medium, the fish is in another medium. So definitely refraction of light takes place. So for the refraction of light means light ray bends and travels. So due to that reason, the bird appears. How the bird appears for the fish which is inside in the water? The bird is in the air medium. So for that we have to find out. So here air medium and the water medium. And these two mediums are separated by a interface is a plane surface. It is not curved. It is a straight, means plane. So for this, for the refraction of light, here in this problem, refraction takes place at the plane surface. For that we have to use the formula is N2 by V is equals to N1 by U. Understand? Now, now according to problem, a refraction at plane surfaces, at a plane surface, that is N2 by V is equals to N1 by U. N2 by V is equals to N1 by U. Now we have to find out what is N1, N2, V, or otherwise first we'll start with the U and V. What are these values? Actually, refractive index. What is refractive index? The speed of the light we are comparing with the speed of light in vacuum. So that is known as the refractive index. So N1 is the refractive index of the first medium. N2 is the refractive index of the second medium. U is the object distance and V is always the image distance. Now here in the problem, which is N1 and which is N2 we have to find out. Actually the light rays, actually for the fish, how the bird appears, that is our problem. We have to find out the answer for that. For this, the light rays falls on the bird and the light rays travel from the bird air medium to water medium. So the rays are coming like this direction. The rays are coming like this direction, and this interface acts as a we will take it as this part optic center, like lens. It acts as lens and we'll take it as this optic center. So from this optic center, always we start measuring the distances from the optic center. So you have to start measuring like this. But the light rays falling like this direction. Understand? For this, we actually in the textbook it is given as actual distance. The bird is, when the bird is flying from the bird to this interface, the distance is given as x. This is the actual distance. This is the actual distance. But for the fish, the bird appears from this distance y. Y we have to find it. So this is the virtual distance, or this is the actual distance for the fish. The bird is flying this much distance, that it is given as y. So we have to find out, this is x is the object distance. X is the object distance. So here we have to take object distance is x, and the image distance we have to take it as y. We have to take it as y, and we have to take always the sign conventions. So I said actually the light rays are coming like this, we have to measure like this. So then x value is positive or negative, we are finding like this. Light rays are traveling like this, so we have to take it as x is equals to minus. In the opposite direction is always negative. And you find out the image of the bird for the fish. So this also, y also same like this only, opposite direction. So v is also minus. Now what is n1 and n2 values? This is the refractive index of air. So the refractive index of air is always 1. The refractive index of water, that we don't know. That we don't know. So that will take it as some n or something. Now we'll substitute all these values in this equation. So n2 means n, v means minus y is equals to n1. n1 is 1 by u means minus x. Here the negative symbol is on both the sides, so you can cancel this negative symbol. Then you will get n by y is equals to 1 by x. When you do that cross multiplication, you will get y is equals to n into x. When you do this cross multiplication like this, you will get the values y is equals to n into x. Now here x, what is x? What is x? Actual distance of the bird. What is y? This is the image of this fish. Now what is n? The refractive index of water. So here in this y is equals to nx, for example, if you take x is equals to 1. If you take x is equals to 1, actually if you refer this Google and all, the refractive index of n or water medium is 1.3. It means more than 1. More than 1. So for example, if you take x is equals to 1, or otherwise you can take it as 2. Then it becomes, if x is equals to 2, then if you substitute you will get 2x. Or otherwise if you take n value is also 2. Suppose for example, or otherwise we will take it as same that value only 1.3. Then it becomes how much? 6. 2.6. Y value how much we got it as? 2.6. If you take x is equals to 2 and we got it as y value is 2.6. When you compare these values, y is greater than x. Y is greater than x. And if you take one more value, for example, if you take 3, if x is equals to 3, then again it becomes y is equals to n into x. N means 1.3 and this is 3.9. If you take x is equals to 3, then you got y is equals to 3.9. All cases, if you take any value, then always we are getting y value is greater than x. Now coming to this figure. In this figure, y is greater than x. For the fish, the bird appears. The fish which is in the water, for this fish, the bird appears. That the bird is coming. Y value is greater. So due to that, the bird is coming farther from the, where is that, farther away than its actual distance. Due to y is equals to, y greater than x, due to that reason, for the fish, the bird appears, it is coming farther away than its actual distance. And when you compare the speeds also, the bird is coming faster. The bird is coming faster than the actual speed. So for this problem, A and C options are correct. Once again, I am explaining. In the problem is given and the 4 choices are given, and they are asking which one is correct. Which one is correct. So for that, by seeing this figure, we have to solve the problem. Clear, children?